Assalamualaikum warahmatullahi wabarakatuh. Today our group want to present about our project Mathematics for Engineering Technology 1 BNR 17803. I will explain about background of differentiation, which is developed by Sir Isaac Newton and Gottfried Wilhelm Leibniz at the late 17th century. So the purpose of differentiation is measure how a dependent variable changes with respect to an independent variable by calculating the rate of which function changes. So the application of differentiation is provide information on instantaneous rate of change by determining a curve slope. And then for the formal definition, it involves the limits of the ratio of change as the interval approaches zero. So the rules is use power, product, quotient, and chain rule to calculate derivative. So the use for physics is to calculate acceleration and velocity. For economic, analyze marginal costs and revenues. Background of integration. Integration, also known as a form of differentiation, is a basic idea in calculus. It was separately built in the late 17th century, also by Gottfried Wilhelm Leibniz and Sir Isaac Newton. A vital tool in mathematics and its application, integration enables the calculation of area under the curves, volumes of solids, and other cumulative measures. Integration, which is closely related to the idea of the limit, is the formal process of adding up infinitely small quantities to determine a whole. The integral of a function is expressed in two forms, which is indefinite and definite integral. Then, the optimization with differentiation. The concept is differentiation is crucial for solving maximum and minimum problem, which are essential in optimization. The goal is to find the maximum or minimum values of a function within a specific range to optimize process, reduce cost, or increase efficiency. The method is first, calculate the first derivative of the function f prime of x and set it to 0 to find critical point. Then, use the second derivative f double prime of x to determine if this point are maximum or minimum or need further analysis. Differentiation and integration of hyperbolic function, inverse trigonometric function, and inverse hyperbolic function are crucial in various mathematical and practical applications. Hyperbolic functions, including sin x, cos x, and tan x, are defined using exponential functions and are widely used in engineering and physics to model phenomena such as wave propagation and heat transfer. Their differentiation follows straightforward rules. These functions have properties similar to trigonometric function, but with distinct application in hyperbolic geometry. Inverse trigonometric functions are essential for solving problems involving angles and distance. Their derivatives are fundamental in geometric analysis and optimization. Integration of this function commonly applied in length calculation and related field. Inverse hyperbolic function bridge hyperbolic function with logarithmic expression, making them useful in growth model and advanced calculus. Their derivative and their integral are significant in physics and engineering, particularly for solving problems and involving natural growth, decay, and complex geometric dysfunction, and their calculus operation provide a comprehensive toolkit for tackling complex problems in science, technology, and mathematics.
Bismillahirrahmanirrahim. My name is Adam Iqbal. My metric number is AN240141. And today I want to present to you about question 1, question 2 and question 3. So for the question 1, determine the point P on the line that is closest to the point 550, 0. What is the least distance between P and 50.0? So firstly, we need to determine the point P on the line, and let's say we put y equal to 2x. We are tasked to finding the point PP on the line y equal to 2xy equal to 2x2. And the point is 50.0 and 50.0, as well as the least distance between PP. and the 50.0. So for the step 1, we present the line equation in standard form. The given line is y equal to 2x, so rewrite it in standard form, and we got the a equal to 2, b equal to -1, and c equal to 0. And step 2, use the formula of perpendicular distance, and we got the answer 44.72, which is the distance. And step 3, find the coordinate of the closest. So right now we use the formula 2, and we substitute the a nilai a, b and c. So and then we got the answer. The closest point is 10, -20. So the final result, closest point is 10, -20, and this distance 44.72. So for the question 2, a cylindrical container with a circular base is to hold 64 inch power of 3. Calculate its dimensions so that the amount surface area of metal required is a minimum when the container is an open can. So for the first one, we need to define variable lah. R equal to radius, H equal to height in inches, V equal to pi r equals to 2H equal to 64 to A equal to pi r equals to 2, which is area of base, and 2 pi r H equal to area of the side. And the total area of that thing is A equal to pi r equals to 2 plus 2 pi r H, and we gantikan H to the formula given, and yeah, we got the answer pi r equals to 2 plus 128 over 2 pi. And step 2, we minimize the surface, which is we differentiate, and we got the answer for r is 2.731 inches. And for step 3, just masukkan in the r in the H before, and we got the same answer, 2.731 inches. And lastly, we calculate the area, and we got 70.30 inches. And for the third one, for the third question, we need to find the critical point, relative maximum point, and relative minimum point, which given y equal to x power of 3 minus 3x plus 2. So for the first one, we need to search for critical number. As you guys see, that is the formula. And yeah, critical point we know 1, f1 and -1, f-1. So we just masukkan nilai 1 into the equation, we got 0. And we masukkan -1 into equation, we got 4. So we know that critical number have 2, and critical point have 2 also. Critical point 1, 0, and another one is -1, 4. So based on critical point, we can use this formula lah. So for the first one, we search value, which is we just insert the -1, and 1. So for the second row of table, we differentiate first, and we insert that nilai also. And at that, after that, we know the sign. If we know the sign, if positive, it will be like this, and if negative, it will be like this. So from that table, we know that which is relative maximum and relative minimum. So relative maximum at the point -1 over 0.4, and relative minimum at 1, 0. Okay, that's all.
Assalamualaikum warahmatullahi wabarakatuh. My name is Afiq Hafizuddin bin Azmi, and today my part is for question 4. So it is determine the differentiation of following function with respect to x. So my question is for number 1 is fx equal to sin 3x power of negative 1. So first we must take the derivative of both sides. So you will get f prime x equal to d per dx, bracket of sin 3x power of negative 1. So with that we use step 2, so chain rule. You will get d per dx, f bracket of g equal to d per dg, uh, what is that? Bracket of fg, my bad, and multiple by d per dx, bracket of g. So g is meaning of g is equal to sin tx. So you will get f prime x equal to d per dg, bracket of g power of negative 1, multiple by d per dx, bracket of sin 3x. So step 3 we will find the derivative. So we will get f prime equal to negative 1g, uh, power negative 2, multiple by d per dx, bracket of sin 3x. So step 4 we will find the derivative of the composite function. So we will get f prime x equal to negative 1g power negative 2, multiple by cos uh, bracket of 3x x 3x x3. Step 5 is we will substitute back the g, that is sin 3x. So we will get f prime x equal to negative 1 sin 3x power of negative 2 cos 3x multiple 3. And next step is we simplify the expression. You will get f prime x equal to negative 3 cotangent, bracket of 3x, uh, 3x and cosecant of 3x. That's all. So for the next question is fx equal to ln x cos x power of negative 1. So step 1, we take the derivative of both sides. So you will get f prime x equal to d per dx, bracket of ln x cos x and negative a power of negative 1. Step 2, we use the differentiation rule. So we will use d per dx, bracket of f multiple by g equal to d per dx, bracket of x multiple by g plus by f and multiple by d per dx, bracket of g. So we will get f prime x equal to d per dx, bracket of ln x and multiple by cos x power of negative 1 plus ln x multiple by d per dx, bracket of cos x power of negative 1. So in step 3 we define the derivative. So you will get f prime x equal to 1 per x and multiple by cos x power of negative 1 plus ln x multiple by d per dx, bracket of cos x power of negative 1. Next, step 4. So we will simplify the expression. So you will get f prime per x equal to 1 per x multiplied by cos x plus ln x sin x per cos x power of 2. So the solution you will get the answer, the same answer, f prime x equal to 1 per x multiplied by cos x plus ln x sin x per cos x power of 2. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal Afiq Abdul Rahman, and my part is question 5. Determine the integration of the following function with respect to x. For the question A, fx equals to x squared times cos secant squared times 4x power of 3. And for the step 1, take the derivative of both sides. F prime x equals to d over dx times x squared times cos secant 4x power of 3 and close the bracket square. Step 2, use differentiation rule. F prime x equals to d over dx, open the bracket, x squared, close the bracket, times cos secant, open the bracket, 4x power of 3, close the bracket square, plus x squared times d over dx, open the bracket, cos secant, open the bracket, 4x power of 3, close the bracket square, and close the bracket. For the step 3, find the derivative. F prime x equals to dx times cos secant, open the bracket, 4x power of 3, and close the bracket square, plus x squared times d over dx, cos secant 4x power of 3 squared. For the step 4, simplify the expression. F prime x equals to dx times sin 4x power of 3 minus 24x power of 4 times cos 4x power of 3 over sin 4x power of 3 and power of 3 again. And for the solution, f prime x equals to 2x times sin 4x power of 3 minus 24x power of 4 times cos 4x power of 3 over sin 4x power of 3 and power of 3 again. And for the question B, fx equals to x secant squared x. Step 1, take the derivative of both sides. F prime x equals to d over dx. X times secant x power of 2. For the step 2, use differentiation rule. F prime x equals to d over dx x times secant x squared plus x times d over dx secant x squared. Step 3, find the derivative. F prime x equals to 1 secant x squared plus x times d over dx secant x squared. For the step 4, find the derivative of the composite function. F prime x equals to 1 secant x squared plus x times 2 secant x times x secant x. Step 5, simplify the expression. F prime x equals to cos x plus 2x times sin x over cos x power of 3. For the solution, f prime x equals to cos x times 2x times sin x over cos x power of 3.